Now let's quickly implement the interpolation searching algorithm that we have discussed previously using the C++ programming language here in this video. So for that, inside this searching folder that we have created, let me just create one file called interpolation search.cpp, and let me just import the basic boilerplate code that we would be using. Along with this iOS stream, let me just also include the vector that we will be using. Okay, now here let me just create one more class, interpolation search. Okay, here let me just define one public method. In this public method, let's write one function which returns integer value in the end, and let's name the function as interpolation searching, and this will basically take the integer values and it will also take the value that needs to be searched in the array of values that we have been given using the interpolation searching algorithm. Okay, so the entire idea behind interpolation searching algorithm is very much similar to what we have in the case of binary searching algorithm. In the case of binary searching algorithm, what we have done, we have been given an array of values which are sorted either in the ascending order or in the descending order. Even in the case of interpolation searching also, it will only work if the array of values are sorted either in the ascending order or in the descending order. So that factor will still remain same when it comes to interpolation searching algorithm as well. But in the case of binary searching algorithm, what exactly we do, we will have the starting index and we will have the end index, and using those two indexes, first of all we will try to calculate the middle index in the array of values that we have been given, right? And if at all, if that middle index is having the value that user has passed, we will basically return that index. Otherwise, we will limit our search logic to either to the left part of the array from the middle index or to the right part of the array from the middle index. So in the case of interpolation searching algorithm also, the entire logic will still remain same, but here we will not calculate the middle index, rather we will calculate the index using the formula that we have discussed in the pseudocode video. Now for implementing the same, what I will do is I will define one variable called start and I will initialize it with 0, and similarly I will initialize one more variable called end, and this I will initialize with the last index in the array that we have got, which is nothing but the size of the array minus 1. Along with this, let me just define one more variable called position, and this I am going to initialize it with minus 1 in the beginning. After this, what we need to do, we need to run a loop as long as the start is less than or equal to the end whatever we have. Along with that, whatever the value that we are searching in the array of values we have been given, right, it should be greater than or equal to the very value that is at the start index. So for that, if at all, if the value is greater than or equal to the value at the start, okay, similarly the value whatever we are searching, it should be less than or equal to the value at the end index. So these two properties should also match. Then only we will go into this while loop and we will calculate the position using the formula that we have discussed, and based on the value we have at that position, either we will return the position itself, otherwise based on the nature of the value that is available at this position, and when it compared with the value that we have been given by the user, based on the nature, we will limit our search to the left part of this position that we get or to the right part of the position that we are going to get. So the entire idea behind binary searching algorithm and interpolation searching algorithm is very similar. Okay, now this position whatever we have, right, this we will calculate by using start index plus, here we need to subtract end minus start divided by the value we have at the end index minus the value we have at the start index. And once we get this one, right, what we will do is we will simply be multiplying this result with value that we have been given by the user minus the value we have at the start index. So this is the typical formula that we will be using for calculating the position. It is just not simple like what we had in the case of binary searching algorithm, but obviously interpolation searching algorithm is not that frequently used. Even if you forget this formula, there is nothing that is going to ruin your day or something like that. It's just that this is one of the searching algorithm, that's why we are learning it. Okay, let me just cross check the formula once again anyway. Okay, we need to multiply this with this one. So the parenthesis was wrong, so that I have corrected now. Okay, now what we will do, we will basically get the value at that position, right? The value at the position that we have calculated. If this value is equal to the value that user has passed, what we need to do, we simply need to return the position itself, because the value is available at this position in the array of values that we have been given. Okay, else if there are two more conditions, right? One is, what if the value at this position is greater than the value that user has passed, and the other condition is, what if the value at this position is less than the value that user has passed. So based on the nature of the value, we will restrict our search range to either left side of this position or to the right side of position, just like what we had done in the case of binary searching algorithm. So here, if the value at the position is greater than whatever the value that user has passed, that means the value at the position is greater than the value that I'm looking for. So the value that I'm looking for is on the left side. So to continue the left side comparison once again, what I will do is I will simply update the end with position minus 1. Okay, if this is not the case, obviously whatever the value we have at the position is less than the value that user has passed, so obviously it will be on the right side, since the array of values that we have got here are sorted in the ascending order, right? That's the reason why I'll update the position plus 1. Okay, now once we complete this while loop, if at all if the value that user has requested to search in the array of values, if at all if it is not available, we need to return minus 1. So that is something that we should never forget, and I have added that here. Okay, now here let me just add the semicolon, and that basically completes the implementation of the interpolation searching algorithm. Now to call this function, first of all let me just copy the common code that we are using, right? Here I think we have added one additional return statement anyway. I've just commented it out. Now here inside the interpolation searching algorithm, let me just paste that, and let me just remove the return logic here. Now instead of jump searching, what we need to do, we need to create the object of this interpolation search class that we have written. So interpolation search, and let's name the reference as is, which basically represents interpolation search, is dot interpolation searching, and this is the logic. Now if at all if our searching logic works as we discussed, okay, the value of 8 is available at index 7 in the array of values that we have been given, right? So that is the output that we should see on the console. So if I just run it, see the output that I have got is 7. Similarly, let's just say I want to search for the value minus 8. Since it is not there, ideally we should be getting minus 1. So that is what we have got here as well. And let's just test it for the very first value as well. Obviously it should return index 0. Okay, that is what we have got on the console. Similarly, let's just try to find the value, something that is in the middle or somewhere else in the array of values. So value 5 is available at index 4, right? So we've got 4. Okay, so that is the interpolation searching algorithm implementation.